Hi everyone, in this video I want to talk about a method of validating the consistency of our ODEs that we generate through our balance equation, which we talked about in the previous video. If you missed that previous video, there will be a link in the description below, and I would recommend checking out that video first and then coming back here, as I will be using the ODE developed in that video as our example for checking our model's consistency in this video. Firstly, what does it mean for a model to be consistent? For a process model to be considered consistent, it means that we can readily solve the problem, and we can do this through validating that our number of unknowns is equal to the number of independent equations that we have. So, in summary, checking the model consistency is just ensuring that our degrees of freedom analysis is sufficient and that the problem is actually solvable. So, how do we go about this though? Well, we need to go through our ODEs and count the number of independent variables. In this example, we have 3, but if we had several ODEs, we would have to do this step for all of them, ensuring that you only count one variable once. So, you never double count an independent variable, even if it appears in both equations. These independent variables are going to be like our accounting system. All of the variables we list here will have to fit in one of the 3 following categories. Each independent variable must be either a constant, an independent that we know, or something that we don't know, an unknown. So, let's just take a second and further clarify each of these 3 categories. A constant is something that is not going to change with our dependent variable. So, in this example, that would be time. A known input is something that we know when studying our system. So, typically, we know our inlet flow rates, temperatures at the inlet, and stuff like that. Lastly, our unknowns is pretty self-explanatory. These are the variables that we don't yet know. In reality, we can make unknowns knowns by taking away a degree of freedom. So, if we didn't know the inlet flow rate initially, we would have to add this variable as an unknown. However, by adding a device to measure the inlet flow rate, or assuming a flow rate, this variable becomes known. Once we have assigned a category to all of our independent variables, we can check our model's consistency. We take our number of independent variables, which we have 3 of, and subtract the number of constants and known inputs. In a consistent model, this newly found value should equal our number of unknowns. This means that our model is consistent and can be readily solved. However, what if the number does not equal the number of unknowns? Well, firstly, ensure that you didn't miss any independent variables in the initial counting or that you didn't double count one of them. Well, assuming that you did this correctly, if the number of unknowns is still higher, then you do not have enough independent equations to solve the problem. This means that you will need to develop another ODE, and this will happen if you have something like a non-isothermal system and you need to solve for something like the water's height and temperature. And in this scenario, you would have to solve a balance equation for the energy. You could also have a scenario where you have the number of unknowns being less than the number of constants and known inputs. Then we would need to do something that I mentioned earlier, like adding another indicator so that one of your unknowns becomes a known. As a whole, it can certainly be tedious to ensure that our ODE makes sense, which we talked about in the previous video, and ensuring the model's consistency. But doing so will save you a lot of headaches. Especially once we get into developing a lot more complicated ODEs, following these 2 steps will ensure that your ODEs are correct, and it is a very good habit to get into. Thank you for checking out this video, and I hope it helped your understanding of how we can check the consistency of a process model. If you enjoyed, please like and subscribe to support the channel. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I will do my best to address your concerns.